Welcome back everybody to part 3 of our beginners tutorial series where we're going to learn how to make a 2D retro platformer in Unity. To pick up where we left off, we have written our code to make our character move, and we've done so in our move player function here by saying that if canMove is true, which is returned whenever we press or hold down a button assigned to our horizontal axis, so the left or right arrow keys, or A and D, that our rigid body velocity is equal to a new vector2, that's a position in our world scene, our game scene, and we're moving along the x-axis at a value that is the sum of the value, the number returned from our input, multiplied by our speed, so positive or negative. The value along y, however, as we're not influencing that value is going to change as we play the game. So what we said here is that the rigid body dot velocity dot y is representative of itself in world space. Speaking of the y-axis, let's go ahead and write a function to make our character jump. The best thing is we are going to reuse this code, except swap around the values that we're going to use. So we're going to be influencing the y-axis and not the x. So let's go ahead and underneath move player type in void jump, we'll call it. Open up your curly brackets there. We need to choose a button first, a key we're going to use to make our character jump. I think the space bar is pretty good, and possibly we could add in the left mouse button as well. So let's start by going if, like we did before, input dot get key down. Now get key down means that when a button is pressed, the frame the button is pressed, something will happen. So what key? Well, we need to name it, and we do that first by typing in key code. Most keys in Unity have names, and we're going to use space. There we go, key code space, or input dot get mouse button down. Now to select our left mouse, we don't type left mouse button, that'll be too long. The mouse buttons have a number assigned to them. Left mouse is 0, right mouse is 1, and middle mouse button, scroll wheel, is 2. So we're going to type in 0 there. Let's close that off. Open up our curly brackets. So what do we want to say that's going to happen? Well, as I said before, we're just going to reuse this code. So select it, copy, and paste it into there. So first of all, let's sort our x value out. And like we did on the y value for our move, we're going to type in the rigid body dot velocity dot x. There we are. That value is representative of itself in world space, because that is going to change as we jump, because we can influence our moving of left and right while we're in the air. And what do we want to say in the y? Well, we have it already written down at the top. We're going to use our variable jump force. No need to multiply. That is a fixed value that we're going to jump by. Before we go ahead and save and test this out in game, we have to call it in our fixed update there. So let's make a reference to our jump function. There we go. Crack a save. Go back into Unity. And when it's compiled, let's go into our inspector, player controller script, and let's add a value, much like our speed, of 5. Press play, and our character now can move, and hey, he can jump. It's feeling pretty floaty at the minute. We can change that though with the gravity adjustments, but that's not bad. Now at the minute, he is jumping, as we said, a fixed value of 5, so a fixed height of 5, and his jump arc is going to be the same distance no matter how long or hard we press our jump buttons. So we're going to improve that in just a bit. However, if you continually press jump, he's going to keep going up and up and up, and this is why nothing's telling him that his feet are on the ground, because we've just said that when we can press space, he's going to jump, he's going to move along the X. So we're going to look at controlling that so we can only jump when our character's feet are on the ground. To do that, let me first explain on the drawing board. Here's a little diagram of how we're going to make this work. We are going to need to create a new game object that will be a child of our player that will act as a checker, a detector, that will let us know that our character's feet are on the ground, or in our case we'll call it grounded. This will be a bool that could be either true or false, much like when we input to move. But first we have to also define what is ground. So ground will be any game object that we want our character to be able to walk on. When our ground checker, which will have a radius, comes into contact with or collides with our ground objects, it'll be true. Therefore, our feet are on the ground and we can jump. However, as soon as we jump, our check is no longer in contact with the ground. Therefore, grounded is false, and we will no longer be able to jump a second time while we're in the air until we return to the ground and our feet are firmly grounded. So to wrap up, we need to define these and tag these as ground, and we need to create our ground check. So let's head back into Unity and figure this out. Let's hop back into our script and start adding some variables to get this ball rolling. We've already said that we're going to use a bool called grounded. So let's go ahead and first of all type in I'll make it public so we can see this in the editor, public bool, and we'll call it grounded. There we go. And we'll also want to use layers, and we're going to filter these layers on which game objects tagged with the specific layer we want our ground check to work with. So to do that, we would need a public layer mask, there we are, and we'll call it what is ground, and we'll say GRD for short. We'll get onto that in a bit. We're also going to need the public transform, so the position and what is to be our ground checker game object, and we'll call that GRD check. Yeah, GRD checker. There we go. And lastly, we're going to want to determine the radius of this object because it's going to be invisible. We're not going to be able to see it. So we'll define how big the radius is using a public float, and we'll call it ground checker rad. Ground checker radius. Great. Now we've got our variables in place. Let's go to fixed update, where we're going to define just exactly what is grounded. What's going to bring grounded as true. So let's click here in fixed update, just above move player there, and we're going to type in grounded is equal, or grounded equals, what's going to equal? Well, we're in fixed update, so we're going to need to use physics here. Physics 2D dot overlap circle, as our ground checker is a circle, and we need to define and place our variables in there now. So at what point, what position is our ground checker game object? So let's define that as ground checker dot position, and we'll position that in the scene when we make it in a moment. Also, our size, we're going to have to define our size with a float, and we've already got that there. So ground checker radius, ground checker rad, and also we need to tell our layer mask, well, what is going to pass through this filter and find ground, game objects tagged on the layer ground. So we're going to define that in the inspector as it is public. So here we can just type in what is ground. There we go. Now let's go to our jump function. Like we've done with move player, we can only move so long as if can move is true. So we're going to put here above our first if statement, we're going to write another one, if, and we're going to call it grounded, of course, if grounded, I'm going to put equals true. There we go. And we can now input this in curly brackets and one underneath there. Save that now, And let's go into Unity. And once it compiles, go to player, go to the bottom there, and you should now see in our player controller script we've had our newly added variables. At present, nothing is going to happen in game because we've not defined what these variables are. We are going to select our ground, hold down Control, ceiling, left wall and right wall game objects, and with them highlighted we're going to go to this here, layer. You can see it's currently set as default. This is where we're going to define what layer they are, and we want this layer to be called ground. We already have 5 here already for us, but we're going to create a new one. We're going to add a layer, and you can click here, user layer 8, and type in ground. Go back, highlight the 4 objects again, click on default, and you should see we now have a ground layer. Go ahead, click that, and no, these objects only. There we go. So these should now be defined as ground. Always make sure. Okay, that's fine. Let's go to our player controller, and where it says what is ground, the layer mask is currently saying, well, nothing is ground yet. We need to define that. So we're going to go down to our newly added ground. So what is ground? Well, ground is ground. There we go. We also have to create our ground checker game object. And we said we're going to make it a child of the player. So on player, right click, create an empty game object, name this one our ground checker. There we go. Its position is fine, but we are going to want to see this in the inspector just so we can move our game object. If you go here to this little box next to our tag box there and select one of these icons, this is going to mark it so we can see it. Okay, there we go. We can't see it because the camera's in the way. And we're just going to move this to the feet of our player, just like that. There we go. Let's go back to our player. And we have said that we have a ground checker transform here, the position and the game object of our checker. So drag that into there. Job done. A radius, we don't have to be big here. We only want it to be small. We only want it to detect when we are on the ground. If it's too big, it can affect how far we can stand at the edge of a game object, and that can cause all kinds of confusion in what's going to allow us to jump or not. So let's just go 0.3 for now. 0.3. Okay. So now, if we were to press play, we should see when we hit the ground that our grounded ball here should be true. There we go. And when we jump, it becomes false. And if you constantly click jump while you're in the air, we will no longer jump until we hit the ground again. Great. Now we've got that sorted. Let's give us a bit more control over the heights and distances of our jumps by adding a sort of pressure sensitivity to our jump function. Let's exit play, go back into our script. I must also point out, you may be questioning why I have 1 equal sign here and 2 equal signs here. If we are assigning values to variables, we'll just use 1 equal sign. If we are looking to compare variables or values, we'll use 2 double equal symbols. For example, here we're looking to see what is equal to our bool. So we want our bool to be equal to true. And if that's correct, something happens. Whereas here, our rigid body dot velocity, we're just assigning what that velocity is. We're not saying it's equal to anything, we're just assigning a value to it. Now let's look back at our jump function. We've already said that when we press a button, our character is going to jump by our jump force. That's dead set, that's fine. We want to put more control on that and determine for how long we can jump for to give us a bit more control over our height and jump distance. As this is a platformer, that's going to be really handy. So we can do that by saying that if we hold down the button, our player can continue to ascend in his jump for a certain amount of time before he hits the ground. Or we release the button that resets the timer so that he can fall back to ground a little earlier. For example, if we just tap the button, that's going to start the timer and immediately reset the timer. So that'll be a short hop. The longer we hold down, the higher we'll jump until we reach the apex before falling back down to be grounded. Before we put in our variables for that, let's write our functions first. So we have if input, get key down, so the first frame the button is pressed, we want to say if input dot get key, and get key means that we have the button held down and it's going to register that every frame. And the same again, we have our key codes. So go ahead and re-put in your key codes from before, keycode.space, or input dot get mouse button, and that mouse button is our left click, so 0. Something's going to happen, which we said is going to be our time of how high we can jump. And we're going to want to release the button as well to reset our timer and bring us back down. And we'll say if inputs dot get key up, which will be the frame that we release the button. And of course, keycode dot space. And same again for our left click. Input dot get mouse button up. You can see the naming conventions there are all very similar. They follow a similar pattern. 0. Alright, so we're going to need a timer here. So let's go up to our variables. And we can do it just below here. Let's type in public float. And we'll call it airtime, for how long we can ascend in the air for. We're also going to need to count down from that value as well. So we'll create a store for that airtime value, and we'll call it public float. We'll call it airtime count. We'll call it airtime count. It's going to store for how long we're going to remain in the air for. In our start function, let's link these two variables together by saying that our airtime counter is equal to our airtime. And we can do that by simply just saying airtime counter equals airtime. There we go. So they're going to be the same values now. Whatever our airtime is, our airtime counter will match that. Let's go back down to our jump function, and we need to say that so long as our airtime counter is greater than 0, we can ascend using our jump force like we did here. So for as long as that timer is greater than 0, we're going to continue to climb. So let's go ahead and write an if statement like we have here. If grounded, we're going to say if airtime counter is greater than 0, what do we want to happen? Well, we want to continue, so we'll just copy and paste this code here because it's going to lift us into the air. There we go. And we also want to say that time is counting down from our airtime count, else we're just going to continue to climb for as long as our airtime is, and we won't come back down. So we've got to reset that value as well. And we can do that by saying that our airtime counter is minus the value equal to time dot delta time. And that's real world time now. That's time that is going to tick down per second, per split second against our airtime counter. So if we have an airtime counter of, say, half a second, that is going to immediately tick down as soon as we jump into the air. We're also going to want to bring ourselves back down to the ground when we release the button by resetting our airtime counter equal to 0. as here we've mentioned that so long as our airtime counter is greater than 0, we are going to ascend in our jump. And that's going to be nice and simple. We can just reset it by saying airtime counter equals 0. As I mentioned before, we're defining a variable, and we do that with a single equal symbol. And when we reach the ground as well, we are also going to reset our airtime counter to match our airtime. So just underneath, right, if grounded is another way of saying if grounded equals true, much like we did with can move. So if grounded, open it up, we can say like we did in our start method, we can just copy and paste that our airtime counter is equal to our airtime. There we go. Save that now. Let's go back into Unity. And once it's compiled, let's start setting some variables. So there's our airtime counter. Remember, we only need to provide an airtime value because our airtime counter is going to match that as soon as our game starts, because we wrote that in our start function. So let's give it, let's say 0.25. So a quarter of a second. Press play. When he falls, have a little play test. So let's lightly press, hold down. See, you can see there is a difference in his jump heights. If I hold down all the way, he jumps that high at a force of 5. We can change how hard and how fast he's going to jump using our jump force. If I lightly press, boop, so it's a short hop. Bee. If I hold down, such a longer jump. Great, excellent. Our game is starting to feel much better. If you continue to jump around, you will notice that when you hit a wall, you get stuck. That's because there's a lot of friction happening here between the two game objects, our wall and our player. We can create a simple little physics material to correct that. So let's stop playing, go to our materials folder, right click inside, create, and we want to create a physics material 2D. Let's call it Slippy, as in Slippy Toad from Star Fox. And you can see there that we have two values, friction and bounciness. Leave bounciness at 0, and we want there to be no friction, so punch that in as 0. Select our player in the hierarchy, and you can see on the rigid body 2D component, it's asking for a material there, a physics material 2D. Go ahead, drag our Slippy material inside, press play to go back in the game, and we should see now that on the ground we are fine, our movement is still pretty tight, but when we hit a wall, there'll be no friction between the player and the wall. Excellent, because the last thing we want is to take a long running jump to a platform only to get stuck on the corner of it and plummet to our deaths should there be a pitfall. Happy days. Okay, let's exit. And in the next video, guys, we're going to start adding in some animations, because at the minute he can move, he can jump, but he's stuck in his default idle pose. So we're going to add some animations for that and start creating a playground for him to run around in and explore. Thank you very much, guys. I hope you enjoyed the video and are following along well. Any questions, please let me know in the comments and I will get back to you as soon as I can, whether here on YouTube or on Twitter at Expat Studios in the corner there. And I will see you in the next video, guys. Take care. All the best.